He really did unplug everything. He unplugs my audio input to switch my iPhone charger input, so my audio is not working. What an idiot. Okay, so today we would like to talk about the FTC Part 1 and FTC Part 2. Okay, so we already talked about that the other day, and I'm just kind of want to rephrase something because a lot of time people don't understand. So I'm going to talk about again just FTC, Fundamental Theorem of Calculus. That's what it stands for. So it's called fundamental. Calculus. Now FTC Part 1 tells you, so FTC Part 1, right? And we're going to talk about what kind of question would they come up with, which is between A and B of non-capital F of x dx. That's equal to f of b minus f of a. This is definitely integral. It turns out we have questions like this on the AP exam. And the way they will ask you is kind of like tricky. It's also you have to understand something else as well. So we're going to come back to that. Oh, actually, I'm going to show you what the question is. So the question that you might see on AP exam is probably something like this. And remember, you had to memorize this question. It's not memorized to understand. Sorry, you have to make sure you understand it because it's definitely 100% on AP exam. So this is AP questions. Make sure you understand. Now, something like this and something like this, you probably have a line. And if you have this f prime of x, so we're going to call this function f prime of x. Now, the way kind of the question will word is like this. They will say, if f of x, now if f of 5 is equal to 17, can you find f of 0? I want you guys to think about how do you approach those questions. Very common questions. Happen very often. Or give me a suggestion how to do it. Yeah.
Would you find like the equation, well, like the slope of the line, like the equation of the line, and then come back to find your f of x?
Well, that's not f of x. That's pay attention. That's f prime of x.
Right, but you need to find f of x, right or
no? Yes or no? Yes or no? And you do have a right start. It's find an equation or a line. We can talk about you can actually avoid it. It will be a lot easier if you avoid it. But you can find equation or line. Yes. It's a good start. Good start. Anything else that may be a good idea? If I give you f of 5 is equal to 17. So this is a question. So this is part 1. So make sure AP question. This is one of the very important questions. I will put a star mark on it or hashtag. Yeah, this is f prime of x. Ethan, are you okay? You look very tired today. Any other idea like can help me solve this problem? F of 5 is equal to 17, f of 0. What Laura introduced says, well, we can find the equation of that line. Yes, you can. And you can take integral of that. But is any integrate from which value to which value? That's probably the question you should ask yourself.
Maybe from 0 to 5.
0 to 5, good. So what we're going to do is we're going to show you a easier way to do this question. So you don't have to find the equation or lines. So easier way is actually understand what is the idea of integral first, or definite integral, right? So there are two things you have to understand. So between 0 to 5 of f prime of x dx. If I integrate of f prime, what am I going to get? F of x, right? And between f of 5 minus f of what? 0. You know what f of 5 is? Which is 17. But do you know what's integration of f prime of x dx between 0 to 5? Yes.
So just area under your equation.
Yep. Area under the curve.
So do like what, 10?
It'll be 1, 2, 3, 4, 5. 5 times 4. So it'll be 5 times 4 over 2. It'll be 10. So f of 0 is equal to 17 minus 10 is equal to 7. And you just evaluate it. You don't even need to have to find equations. Now, some people is going to do this a longer way to do something, which is this is a longer way and much longer. So they say integration. They either do it definite integral or indefinite integral. If they do it indefinite, it's even longer than that. Okay, so some people do it this way. They figure out what the equation is, which is negative 4 over 5x plus 4 dx. And they do integral of this. And they find out what the original function is. Like what Laura suggests is find out original function. And that's not wrong. That's actually a good method. But it just takes a long time. And if it take a long time, you waste time on your test. You don't want to think about that. You just think about the idea of area under the curve, which is 5 times 4 divided by 2. Does that make sense? Now, if I do it indefinite integral, then I have to find the value of c. Now, with f of 5 equal to 17, I can find the value of c. Then I just plug in 0 after that. But the work is actually quite a bit. So if you think about the work of this, it's much more complicated. So minus 5 over 5x squared over 2 plus 4x plus c. Now, this one is, I think this is way too much work. It's a good idea. You will get the job done. This is f of x, and you can figure out what is f. You already said f of 5 is equal to 17, and that's equal to 17. And I will plug in 5, and you find evaluate c. And then you plug in 0 after that. You can get the same job done, and you're going to get same value 7. Do you see what I'm saying or no?
Yeah.
But that's way too much work because the c are subtracting each other. Anyway, so it will be much longer way to take care of something. Now, if you prefer this way, you're going to get the same answer regardless. It just work is going to require probably 3 to 5 minutes longer. So I will actually ask you to understand this because it's much more efficient when you're doing something. So I won't even go to definite integral. Now with the indefinite integral, with the definite integral, you can do a boundary between 0 to 3 on the functions. But that's just going to give you the area under the curve, and you have to subtract to the other side anyway. So actually, it's still longer. So this is probably the best way because the area under the curve is the integral. Does everybody understand that?
Is the fundamental theorem of calculus a given equation on the AP exam, or is that one?
Oh, it's a big part of AP exam.
No, like on like the equations sheet for like AP calculus.
No, they don't have an equation sheet at all.
Oh.
There's not like physics.
Okay.
So they don't have formula sheet, but I will give you a formula sheet that you have to go through and make sure you memorize it.
Got it.
The student that went to MIT, me and her kind of collaborate to do a formula sheet that makes sense for all the students, and she did it very well. Like even you can like search and you can go directly like average value and it just goes there.
Okay.
I don't know how she did that, but questions? So this is a fundamental theorem calculus 1. Now we're going to go to fundamental theorem calculus 2. So FTC, right? And we talked about this last time. FTC part 2. Part 2 just basically integration between 0 to the x, and which is d to the dx. This is the only part that's different. And that if I have some type of, let's just say, some type of functions, we're going to say f of t dt. Doesn't matter. You can use t or use x. It doesn't matter. That's just equal to f of x. And we talk about this is a perfect case. This is the perfect case. Why? Because this is fundamental part 1 and this is a part 2. Is take derivative of the part 1 becomes part 2. Now usually you're gonna get boundary as a variables. Is a variable. Some type of x. It could be sine of x, cosine of x, it could be anything. Could be natural log of x, could be other things. Are we okay? Now one cool thing is when you have fundamental theorem of calculus part 2, is you don't have to know how to take integrate of a functions. And I think we give you an example. I forgot which example I give it to you. Oh, we didn't in this class. We didn't even start it. We says, hey, can you take integrate of natural log of t dt? And between 0 to x, again, the x is a different color. I will show you because the only time that you have a boundary of x like this, that's where things change. That's what you can tell. That's a fundamental theorem of calculus. If boundary is not a constant. If boundary is 2 and 5, you don't need a fundamental theorem of calculus 2. Now what I'm gonna do is I'm gonna says here's the truth. No one in here, even in BC Calc, know how to take integrate of natural log of t. No one. In all my classes, all 6 classes, including BC, doesn't know how to take integration of natural log of t. Today we're going to teach it actually. But the thing is, we don't need to know how to take integration. Here's the reason. If I'm taking integration, if I'm going to take a derivative afterwards, I don't need to know how to take integration. But what we need to do is we can assume something. So what we're going to do is we're going to assume that, say, we're going to use a different variable. We're going to assume g of t or f of t. Doesn't matter. You can use f of t, g of t, h of t. Doesn't matter. That's just a function. The function has a name. And we're going to name the g. So we're going to say g of t is equal to natural log of t. Does that make sense? And then what we're going to do is we're going to change this to d to the dx with integration of natural log of, instead of natural log of t, I'm going to do what? G of t. Does that make sense? Between 0 to x. We got this? What's integration of g of t? What's the integration of g of t? Just a notation difference, yes.
So that's capital G.
Capital G, yeah. And according to fundamental theorem calculus, that's just g of x minus g of 0. Does that make sense? Am I going too fast? For a non-G, non-capital G to increase, to take integration is going to be capital G. Yes?
So for capital G is G of x minus G of 0?
Well, usually there's one more step, is d to the dx of, if I integrate of that, it's going to be g of t between x and 0. That's how to write it, the line, a straight line. That's a boundary. So if you integrate as a non-capital G, it's going to become a capital G. Does that make sense? Then I just plug in boundaries, subtract each other. That's fundamental theorem calculus 1. So that'll be g of x minus g of 0, which is capital G. Now afterward, I'm going to take a derivative of this. If I take a derivative of this, and if I take a derivative of this, that's going to give you what? A non-capital X. Does that make sense? Now, I have to take a derivative of the inside. So derivative of inside is 1. I use a different color to show you this chain rule. Minus g of 0 times derivative of 0, which is 0, which is here is a chain rule again. Right, it's a chain rule again. So they just go completely away. Does that make sense? That's g of x. Eventually we're going to get g of x. And we already know what g of x is. We know g of t is natural log of t. G of x just becomes natural log of x. And they go back to before. Now this is a perfect situation, though. This is a perfect case again. This is a perfect case, right? What happened if the case not perfect? I'm going to give you a question that's not perfect situation, which is I'm going to say d to the dx of integration between 0 to x squared. Do you see that x squared is a variables? So that means whatever answer you get result should get the expressions. Then you're not gonna get evaluation. So here it's gonna give you we're gonna give you 7 functions. Natural log of t dt. Now you're gonna see this imperfect case. We're going to do exact same thing as before. If I do exact same thing before, what will happen? D to the dx, and we're going to assume natural log of t is equal to ft. This is such an important step. We're going to use g still. So that way we're not changing it too much. And we know it's going to be big G of what? Sorry. Integration of g of t dt between x squared and 0. What am I going to get here? Big G of 0, right? Minus big G of x squared, right? Am I going too fast? Now we're going to take a chain rule. We're going to take a derivative of this. Derivative of this is going to be g of 0 times the chain rule, which is what? 0 minus g of x squared times what? What? 2x. Derivative of x squared is 2x. So that's equal to g of negative g of x squared times 2x. Well, we know g of t is equal to natural log of t, so that's going to be natural log of negative natural log of t squared times 2. Sorry, we're going to x squared, sorry. X squared times 2x. And that's my final result. Remember, it's not the same question as before. Same expression as before. Before we got natural log of t. But the problem is a chain rule. You have to take a derivative of the outside and take a derivative of the inside. So don't ever forget that. I'm going to give you a super hard questions. Oops. That question is going to be 1 minus t squared dt between sine of x and cosine of x and the d to the dx. Now, the answer you're going to get on this one is going to be a constant number, a very cool number, really easy number too. If you get it,